last lecture we have seen the symmetrical numerical on I section or rectangular section. But before going on the unsymmetrical section numerical, you know the how to use the parallel axis theorem. Okay, what is the parallel axis theorem? We have considered the moment of inertia about any axis. Okay, I will consider here one axis AB. The moment of inertia about any axis AB. The moment of inertia about any axis AB. It is the algebraic sum of the axis IXX, or we can say the centroidal axis. Okay, suppose here is a centroidal axis XX. This is the algebraic sum of the centroidal axis, or it is also denoted by the I suffix G. This is the centroidal axis. Okay, and the product of the area about that centroidal axis. Okay, I will consider here one area about the axis, moment of inertia about the axis XX. Okay, suppose here is a area of that body. We will consider one area, and the centroid of that body is XX. Okay, at point G. At point G. Then how to calculate this? We will consider the small element area delta A. Okay, suppose here from that area I will consider this is the small element area. You have to calculate that distance. Okay, this distance is always vary. You will get the different value y1, y2, y3, y4. That value you will get the different value in the given component. Suppose if you have considered the three parts in a body, then you will get the three different value for that, because you will get the different area. Here we will consider the small area here. Some body will consider the here. This y distance will be changed. Okay, and also we will consider that distance between centroidal axis and reference axis. And what is the parallel axis theorem? This parallel axis theorem is state that the moment of inertia about any axis means here we can say the IAB axis. Okay, moment of inertia about any axis, and it is the algebraic sum of the moment of inertia about the which axis? Centroidal axis. And it is the product of the given area. It is the product of area of the section and square the distance in between centroidal axis and reference axis. This is the parallel axis theorem. Okay, all of you getting what is the parallel axis theorem? You have to remember that equation. IAB is equal to IXX plus A square. Some books you have given IXX is replaced by again IG. IG is again centroidal, moment of inertia of the centroidal axis. Okay, we will solve the numerical, unsymmetric numerical with the help of that parallel axis theorem. Okay, then how to solve? I have taken here one example. See this example, here is a T joint is given. Okay, here you have given the simply supported beam. Load is given at the center point C. Okay, center point C, W load is given, and length is given, or total span is given 2 meter. And you have given the I section. Here is you have given the T section. Okay, the top plane dimension is given 120 by 12, and web dimension is given 38 by 12 is given. And also you have given the bending stress induced in the tension condition 100 MPa and bending stress is induced in the compression condition. You have one 150 MPa, and what we want to find? We want to find out the set load W. Okay, if the stress is induced in that T section 100 MPa and 150 MPa, then we want to calculate the value of W, set load. There you will get the two values for the tension and compression. Then how to calculate that W? See, this is the not symmetric figure. Okay, symmetric means what? If you have taken the section, up section of that object, then you will get the same image above that section and below that section. Means mirror image. This is called symmetric. But this figure is a unsymmetric. Then first, what will require? We know the bending equation, m by I is equal to sigma by y. We want to that equation and calculate the value of W. Then how to calculate? First step is we want to calculate what is given. Simply supported beam is given. Simply supported beam. Where will get the maximum bending stress? Then Cm value. Okay, remember the formula, sigma by is equal to m by I. Okay, one by one we will calculate. First we calculate the m, maximum bending moment. How to calculate that maximum bending moment? You know that for the simply supported beam, standard condition is given. See, which standard condition is given? Here is, I will consider this is the AD, and there is a at the half distance or center W load is at, and this span is given L. For that, if you have calculated the maximum bending moment, then you will get the WL by 4. Okay, if you have calculated M is equal to, then you will get the WL by 4. How to get? If you have calculated the reaction, suppose RA and RB, then you will get the W by 2, W by 2. This W by 2 into this, if you have taken the moment above that at point C, then take that W by 2 into 2 is there. Here is a half distance is there. Okay, total span is given L. Then you will get the W L by 4. You have to calculate that value. Take the moment about that point C. Okay, then you will get the maximum bending moment point at the center. M is equal to WL by 4. Okay, then put the value W. We don't know. We want to calculate that W value. And L is equal to what? L is equal to total span is given 2 divided by 4. 2 divided by 4. Then 2W divided by 4 means W by 2 is there. Can I write here? W by 2 means again 0.5 W Newton meter. A moment means what? Force into distance. Force into distance. Force into what? Distance is there. Then you will get the 0.5 W will convert into the Newton mm, then multiply by 1000. 1000 mm is equal to 1 meter. That's why 500 W Newton mm. Okay, first value we are getting m is equal to, I will write here, m is equal to 500 Newton mm. Okay, 500 Newton mm. We will get this value. Then after that we want to calculate the y bar value. Okay, then where is our neutral axis or centroidal point of that body? Okay, I will consider this is the first part. Okay, where is the first part and second part is a flange, top flange in the T joint. Okay, then how to calculate the y bar? Where is the centroid of that body? There is one formula, y bar is equal to a1 y1 plus a2 y2 divided by a1 plus a2. Use this formula and calculate the y bar value. How to calculate the a1 for the first part? We will consider the only pair. Check that. Depth is given 38 and width is given 12. A1 is what? I will write here. First calculate that one by one value because we will require A1 is equal to 38 into 12. 38 into 12. Okay, this value I think 38 into 12 you will get this A1 is equal to 38 into 12, 456 mm square. Remember that. Then what is the value of y1? y1. How to calculate that y1 value? Remember that y1. How to calculate? You have to consider only the web. y1 means centroid of that web. Centroid of that web. Where how to calculate? There is total depth is 38. 38 divided by 2. That's it. 19, 19 mm. Okay, getting y1 means what? This distance, centroid of the web. 38 divided by 2 is there. Then the second is area 2. What is the area 2? Area 2 is equal to what? This second part. Only think about the top plane. 120 into 12. 120 into 12. What is the square of 12? 144. 0 is there. Right? 1440 mm square is there. And what is the y2? How to calculate that y2? Remember that we are thinking about only that. You are going from the bottom to top. Okay, you can start from the top to bottom. You will get the same value. But you will get the above part value, not below part value. Okay, y2 is equal to what? y2 how to calculate? What is the centroid of that depth? 12. 12 is there. 12 divided by 2. How to calculate that? Remember that or note down anywhere this formula. Here is a d1 by 2. I will calculate here d1 plus d2 by 2 is equal to. Okay, this distance. I will mark here. This is the y2 and suppose half distance of this. This is the y1. Okay. In first figure you have to mark this y1 is equal to what? Total d1 is equal to 38. 38 plus this 12 divided by 2. 12 divided by 2. 6 is there, means 44. 44 mm. We have calculated value a1, y1, a2, y2. And put this value in that equation. Then check that. Put this value in that equation. What is the area 1? Area 1 is equal to 456 into what is the y1? 19 is there. 19. What is the y1? Again y1 is the 19 plus area 2 440 into y2 44 divided by area 1 plus area 2. 456 plus what? 1440. Then you will get this y bar is equal to when you solve this y bar is equal to you get the 37.987 mm from bottom. If you have calculated from the top, then you will get the different value. Okay. Then I will mark here the y1 value. Y bar is the centroid of that body from the bottom. If you have considered, then you will get the y bar is equal to 987 mm. Okay, this value we are getting. Then next step, remember that we are getting the y bar. Then then we will going on the I. How to calculate the moment of inertia about the centroid? Okay, this axis, x-axis. Okay, then how to calculate? I will write the formula here. Ixx is equal to, see, we will calculate for the first part and second part. That's why you will get the two different moment of inertia, Ixx1, Ixx2. There are two moment of inertia. And how to calculate this? With the help of parallel axis theorem. Okay, what is the parallel axis theorem? Here is a ig plus ax square, ig plus ax square plus first part, and second part ig plus ax square, again same. Okay, again what is the ig? Ig means what? Bd cube divided by 12, because here is a rectangular part, right? What is the area of the first part? Then h means what? H means distance between the reference axis and centroidal axis. How to calculate here that distance? Remember that h means you will get the y bar minus y1, y bar minus y1. Okay, get it? Getting? Plus, then next one again here bd cube 12 plus a into h square, means y bar minus y2 square, y2 not y1. Okay, this is the formula you have to use. Remember, this is the generalized formula for the parallel axis theorem. Why we are taken here again bd cube divided by 12? Because second component is again rectangular component, that's why we have taken. Then what is the b? What is the b for the first part? Check that 12 is there. What is the d? 38 cube is there, divided by 12, plus what is the area? We have calculated the area one value. What is the value of that area one? 456, na? Yes, check that. 456. What is the y bar? We have calculated 37.987 minus y1. Minus y1. What is the value of y1? 19, na? Yes, 19 is there. Bracket square. Plus again, what is the bd cube divided by 12? This one, bd cube, d is 120, 12 cube divided by 12. Again, plus, check that, huh? Plus, what is the area? 1440. Then, what is the value of that? This one, 1440 into y bar, again 37.987 minus what is the y value? We have calculated 44, bracket square. Then this is the, then you will get the ix is equal to, and you find out, solve this, then you will get the ix is equal to 288.606 into 10 raised to 3 is there. What is the unit of moment of inertia? Mm raised to 4. Mm raised to 4. Hence I will write here ix is equal to 288.606 into 10 raised to 3 mm raised to 4. Once you get the value of moment of inertia about the x axis, all of you ready how to get this h? Check that, I will explain. This 37.98, okay, 987. This is the y bar. This is the y bar. And where is the y1? This is the y1. The distance between from these two, reference axis and centroidal axis, you will get the h. h1 is there, means square is there. Okay, and second one, this centroidal axis to h2 is this distance, h2 up to this. Okay, this will give the h2. Okay, remember that you will get the h2. Okay, you can minus from this 44. What is the y2 value? We have calculated the y2 is equal to 44 is there. 44 is there, right? And where will get the h2? This 37.987 minus this 44, means remaining value is what? Remaining value you will get for the h2, or you can write the 44 minus 37.987 means what? y2 minus y bar. Okay, you will get the same answer because of square is there. Okay, if there is this sign will be changed, no issue, because square you will get the positive. That's why keep as it is. Once you have calculated that ixx, then use the formula. This M by I is equal to sigma by Y formula, bending formula. Okay, before going on that formula, you have to check the where we'll get the compression and where we'll get the tension. Okay, we have seen in the first lecture nature of the bending in the simply supported beam. Here from the neutral axis, above the neutral axis, you will get the compression. And this value is given for the YC, and here is the sigma C, and this value you will get the YT, means sigma T is there. Below the neutral axis you will get the tension, and above the neutral axis you will get the compression. Okay, here you will get the compression, and here you will get the tension. Okay, remember that this figure is very important, bending stress diagram. Then how to calculate the above value? How to calculate? We will know the total depth. Okay, I will write here y bar is equal to what? Y bar is equal to what? Below the neutral axis, yt is there. Then tension value is equal to 37.987 mm. And next is a what is the YC? YC, how to calculate the YC value? This remaining value is a YC. This total depth is a 38 plus 12. You will get the 50. Means 60 minus 37.987 mm. Then YC, you will get the YC value. Check that value. YC is equal to, you will get YC is equal to 12.013 mm. YC is equal to. Remember these two value. Okay. Once you have got these two value above the neutral axis and below the neutral axis distance, then easily we can solve. First condition is a, say M by I is equal to sigma by Y. What do we want to find out? We want to find out the W value, right? What is the M is equal to 500 Newton mm. W is there, huh? 500 W Newton mm. W is the constant. We want to calculate. I will shift this. M is equal to sigma. I will write first T into Ixx divided by Yt. For the tension condition, we will find out M value. Okay. M is equal to what is the sigma T? Sigma T is already given 100 MPa. MPm is 1 MPa is equal to 1 Newton per mm square. Remember the relation. 100 into what is the Ixx value? I have written here 288.606 into 10 raised to 3 is there. This is in again mm raised to 4. And what is the Yt value? 37.987. This you will give this M is equal to first value. M is equal to what? What is the value of M? 500 W is there. This is again Newton per. Then you will get the W is equal to 1519.498 mm. Okay. You will get the for the tension. You will get this value 1519.498 mm. Similar way, we want to calculate for the compression. M is equal to, I will repeat that equation, sigma C Ixx divided by Yc. Okay, here is the M value is 500 W. Sigma C, what is the value of sigma C? 150. What is the value of Ixx? Same value. Neutral axis 28 point into 10 raised to 3 divided by Yc will be changed. What is the value of Yc in compression? This value we have calculated this 12.013. Okay, then what is the value of W? W is equal to, if you have calculated, then you will get the 7207. This is in Newton, not mm. Okay, load is given in Newton. Okay, Newton. Check this two value. What we want to find out? We want to find the self load W. Okay, shape load. If you are acting the maximum load on that T shape of the beam, okay, simply supported beam, then this will be bent. Okay, we want to apply the shape load. Then which is the shape load? You have to choose the least value out of from this two. Okay, which is the least value? This is the least value. First one is the least value, tension. If you are applying that second value, then this beam will be bent or break. That's why I choose the shape value, which is the shape 1519.498 Newton. Find the shape load. This load will act on the simply supported beam. All of you getting how to use the parallel axis theorem, or how to calculate the value of Ixx, how to calculate the value of Yt, how to calculate the value of Yc, then Y1, Y2, okay, and Ex value. This is very important. You have to remember this any one figure. Where is the Y1, where is the Y2, where is the H1, where is the H2, where is the H2, okay, then easily you can calculate the value. Okay, getting? Yes, today we'll stop here.